Hi, I'm Alison Scorese. I am a rising junior, and I am a chemistry major working with Professor Dina Mehrer, the department chair of chemistry. And the Mehrer group studies reactions of carbenes with different substrates. Specifically this summer, we looked at the reactions of carbenes with strained pi substrates. So at the beginning of the summer, I and my two lab mates were each assigned a compound with a strained pi system to synthesize. And these compounds were dibenzocyclooctadiene, which is right here, dinaptocyclooctadiene here, and then my compound that I synthesized was dinaptocyclooctadiene right here. So we followed a synthesis that was laid out for us by Paul Wender and others, but we changed one step so that we would avoid a cyanide step, and the synthesis was successful. It's listed here. We started out with bisbromomethylbenzene, and we installed two new carbon bonds in the first step. Then we did an electrocyclization reaction to form the skeletal structure. And finally, we finished off with an aromatization step, which allowed us to synthesize my compound. And this compound was characterized by nuclear magnetic resonance spectroscopy, which is basically like an MRI on molecules. It allows you to characterize your compound based on where the hydrogens are in the compound. It tells you about the atomic connectivity, and the signals given in the nuclear magnetic resonance spectrum tells us where the atoms, where the hydrogens are connected, and they give characteristic signals based on which compound you have. So these signals matched up very nicely with the ones given by the synthesis in the Wender group. We did this with hydrogen NMR and also carbon-13 NMR, which is down here, and it works the same way. It tells us what our compound is based on where the carbons are in the compound with the signals. So this is how I characterized my compound. I also looked at gas chromatograms of my compound, and we, in order to get our gas chromatogram, we did gas chromatography, which allows you to see the compounds in a mixture based on their, it separates them using a column based on their polarities and their boiling points. We have one listed here for the dibenzocyclooctadiene compound, or one of the precursors to it. It gives one peak, so it shows us that it is pure, and it is a pure mixture actually of these two isomers of the precursor. And the other compounds being synthesized by my lab mates are still in progress. They will also be characterized by NMR, as we see here. And we are still looking at alternative syntheses to see whether or not these will work. And then once we have synthesized these compounds, we are going to irradiate them with ultraviolet light at 350 nanometers, and we are going to react them with something called phenylchlorodiazerine, which gives us phenylchlorocarbene, which is one of the carbenes that the Mehrer group studies. And we expect addition of the carbenes to the most reactive double bonds or triple bonds in each of our compounds. Those are on the top and bottom of the 8-membered ring in each of our compounds. So we expect these products, depending on which starting material we started with, and you will get we expect to get a cyclopropyl ring either on the top and bottom, or only on one side.